Okay, alright, selamat datang, welcome everyone. So this is my week 2 recap, what I did for this week in my learning journey. So it's quite a hectic week with a lot of meetings and new projection for this year in work. But also I'm trying to not to lose my feet with other things also, with my learning. So as planned, I managed to execute some of it, and some of it I planning to move forward for this next week, week 3, progress of learning. Also, we have some uh, additional stuff, and also I managed to publish my K6 presentation article, and also my thoughts on why K6 is useful for API testing and etc. So yeah, let's move on. So first stuff is I managed to revamp my portfolio to use Hashnode public API and directly retrieve GitHub repos at my YouTube and also at my YouTube playlist, basically this weekly recap playlist. So let me show you the portfolio. So here we have, hi, hello, I'm Mani Akil, and also my article, and also this project for in my GitHub, and some articles. So I plan to write article occasionally if I have anything to share, and also it will do great for my learning, and I think it will make me think more about something that I did, and maybe have some thoughts, or I can share with others what I've learned easily with just this article. So let's see what the article I just published. So basically this article was from my other repos. So I just transfer it into this Hashnode blog here where I manage my article. So I just have to like write, create new article, and then publish as usual, and it will appear in my personal portfolio. So it's easy. Just fetch some JSON and stuff, and yeah. How about we go through for what? So I did performance testing with K6. So what is K6? K6 is a load testing tool created by Grafana, and also I explained my experience about it. So and what its benefits as the team, and why we can utilize it for performance testing and also reliability of our APIs. So check it out. And also just some thoughts, small thoughts, and also how types of scenarios that can be done. So most of it I extract from the docs, and also some thoughts by myself. So move on to the next thing. Let me show you the code first. So this is the code for my portfolio. So basically I revamped the last year portfolio. I forgot to record the last year portfolio, what it looks like. Basically it's similar. It's just that I think I add more additional and like unnecessary stuff in there, like mind map, and also my article, and then display inside the portfolio. So here is the GitHub, how I patch it. Basically I just white code it, honestly, and and tweak here and there, because I believe this is just for visibility of my work. So the real work comes with the next project that I will share. Nothing much, just simple page and simple web app. Let's move on. So next, what I did is I read system design. So next is I managed to read system design, 2 chapters, which is one is scale from 0 to millions, which is I understand about web server, domain name server, DNS, load balancer, cache strategy, database, how to scale it, CDN, how it supports scaling and performance, shared DB and data center, and many more. So let's see drawings that I just draw to represent what I learned. So inside the system that we want to build, basically we have a DNS, a user, mainly CDN, and a web server. So and then we scale use basically DNS is a third party, CDN where we store image or any digital assets. So we don't have to like go through the web server, because no processing needed. And we have different data center here to support to improve the latency. So basically, if that one data center in Malaysia, Malaysian user oftenly will be load into the Malaysian data center instead of somewhere in Europe or in Korea or the US. So this improve latency logically, and then load balancer will probably manage high traffic and distribute evenly. So let's say we have 3 data center in Malaysia, and everyone is in Malaysia, it still will distribute the request evenly to make sure the traffic is handled fair across the data center. So this will help not to overload any request. So inside the data center, we have web server, where the usually the operation, the backend will run, and then we have message queue, catch and database and worker and NoSQL outside. I mean, NoSQL is depend. So let's start with the basic first. So basically, we should have web server and databases. So so extension of it, we have message queue and worker to work on the asynchronous messaging operation. So let's say we have photo to upload, and the worker have some function to edit stuff. So this usually will take time, and if it's not if it doesn't use the message queue, it will cause slowness. So what does message queue provide is it will asynchronously handle the queue and helps user to move on to other stuff first. So if we notice like Instagram, when we push story, it will have a this loading image icon, means that it's still in the queue. It's just that it's faster lah, because yeah, it's a big operation, big system. And then we have catch, which kind of temporary storage for our database. So instead of queuing database back and forth, it helps to store temporary and frequent data that used by the user. So it will reduce significantly use of transaction in database, which will cost lesser and also fast. It's just that catch have its own methodology of eviction policy, expired policy, and consideration to use catch. So I would say when using catch, you will need to decide whether how long do you want to persist the data, and set the expired. It must be not too short and too long, and the eviction policy must be decided whether you want to use the LRU method, FIFO method, or LFU method, etc. And also other thing is databases. You can have one scaling can done is vertical and horizontal. So if you use and other thing is you may create a database replication using the master slave method, and also you can scale vertically or horizontally. If you scale horizontally, you can do sharding and etc. And next you have this NoSQL. So NoSQL usually used for shared storage. So NoSQL basically helps your system to be stateless instead of stateful. So everything it will fetch some data in the NoSQL as a and get out of the web server, because it will be more robust and scalable. Basically for like user ID, user account, you use NoSQL lah. And then lastly, we have logging and metrics and monitoring. So basically this is optional, but it's good for insight and also debugging. If you can like study and calculate how much you will use and prepare for any cases that will cause you to scale more or can scale less in certain season or etc. Yep. So that's a system design for scaling 0 to millions. And next is back of the envelope. So this I'm not totally master yet, but I understand what's the reason of this chapter is to plan the capacity for when to plan the resource and not to be over budget or over provision or under provision and cause to the system or the business to rugi or to loss. So here we understand what are the calculation and the power of two calculation, the availability number, so how much downtime and downtime per year, latency number. So this is I can't remember this all, but I know it's this, so I can quickly refer. And then some calculation. So example is the query per second example, some tips, and I would like to go through this, but but it will take a long time. So this is a good practice to estimate the real world use case, and when interviewing, I guess if the interviewer asks about how to plan the system, so maybe we can start with back of the envelope calculation, understand the SLA and etc. So this is great reading, but definitely I will have to practice more on the estimation and decision when being asked. I'm not worried, but it feels great to know this stuff is actually utilized, because previously I was thinking how does the seniors do this calculation and stuff, and do they have a template or where do they learn this? Because I didn't remember having this topic back in the study day. Maybe I forgot or something. So it gives me an idea of where does this system design interview came from, and how do people manage to calculate this stuff during interview or during the application planning. So we'll keep on digging into more chapter and get more idea and increase my knowledge on system design. So next is this is the fun part. I managed to refactor the Malaysia runner list aggregator system, which I postponed quite a long time, 6 months or 8 months, I think, the last commit. So yeah, I refactor it into Monorepo, but it's actually a single repo, but for development, it's better to have Monorepo set up. You still have to commit it with single repo each time you make a change. So yeah, this is the structure. You can see I can't wait to complete this project and finally write the technical documentation and decision. So yeah, of course, with the help of AI, it's making things quite quick also for me to like code it everything. So like I just decide the design and system of separation of concerns. So like API, I want it to be this structure follow hexagon, or we can say adapter structure, where we handle the adapter, the external endpoint here, we handle config here, we have core where we decide our domain, which is our model, and our service. So basically our API, and then finally we handle our API here. So the improvement I did was basically most of it the same. It's just that I add the internal routes for database sync from the scraper. Yeah, I finally managed to scrape, and yeah, I also restructured. Basically, the previous scraper is basically empty, just one Python code and the results of not working. So yeah, this time around it works. And yeah, let me show you the README. Yeah, I think it's better this way. Yes. So this is the README of the scraper, and the structure I did. I followed the API structure a little bit, but I guess it's enough for me at least to separate the function of each of the code inside the scraper, so that it won't be too messy. And some of the output and some description probably. And then next is the API. For the API, it's more complete, I guess. I mean, it's more fun to look at because it has this its own design. So the hexagonal architecture, I would say, about adapters and how to host it. And yeah, next is to try and sync the scraper, to create the scraper to have a post function to post the results into the API and store it in the database. And then I will create a daily or weekly cron job to scrape the data in from the website and serve my own database, and finally integrate it with my client. Client has just used the normal Next.js app and will consume the API. So bigger feature will be added soon, I guess, after I manage to deploy all of this and it works for a few months, for 1 month. Then if it works, I think I will plan more features that are beneficial for the Malaysian running scene. So let's move on to the lead code Python question. I didn't manage to start the lead code yet, but I managed to speedrun the Python for coding interviews. So next week I'll try to week 3 lead code, more system design, basically finishing the books and share with you guys and share what I gain. And yeah, the infra cloud engineer with Go. So yeah, that's all. Okay, that's all for me. See you next week. It's hiccup. Okay, see you next week. Thanks, guys.